Welcome back everybody. The topic of this video is caching. The best way to introduce the concept of caching is to use this library analogy where a student who plays the role of a processor is working on an assignment. The desk that can hold that many books represents or plays the role of the cache, and the bookshelves play the role of the main memory. The idea is that the student is working on the assignment, and whenever some information is needed from a certain book, the student goes and fetches the book and places it on the desk. Initially, the desk is empty, but the more information is needed, the more books will be brought and available on the desk for the students to access very quickly. Accessing information from the books on the desk takes very little time, is very fast, very efficient, very few clock cycles. Whenever the student needs to go and fetch more books from the bookshelves, that takes much longer, many more clock cycles, and that is undesirable. So ideally, the ideal mode of operation is that the student, whenever she needs that information, the information is available in some book on the desk. Now, in order to help with that, whenever the student goes and fetches a book from the bookshelves, the student fetches a bunch of books, books that are in the vicinity of that book, because most likely the books in the vicinity of a given book will contain information that the student might need later on. And by fetching more of them at the same time, a bunch of them, the chances that the student will have to go again and fetch those books will be less. And in this way, the likelihood for the information to be found in books that are already on the desk is higher. So that exploits a concept that is called the principle of locality, and that is spatial locality, in the sense that spatially books that are clustered nearby with each other more likely contain information that the student will need and utilize. So by fetching more books at the same time, you increase the chances for that information to be found quickly on the desk. That plays the role of the cache. The other important side of the principle of locality is the temporal locality, meaning that information that is being utilized now is more likely to be utilized in the near future by the student rather than in the far away future. Therefore, the idea to exploit this temporal locality is that when the desk is full of books and you will have to return some of them in order to make room for some new ones, the idea is to replace and put back into the bookshelves the books that have been utilized a long time ago. The ones that have been utilized recently, keep them, because in this way one exploits the principle of temporal locality, meaning that the information that has been recently utilized is more likely to be utilized in the near future rather than in the later future. So that is the idea of caching, using the desk as a cache to hold the books that will provide information very quickly to the student, and operated based on these ideas of exploiting the principle of temporal and spatial locality. So in the world of computers that use memory hierarchy, the caching that sits very close to the processor is very small as a memory capacity, but fabricated, implemented using fast memory technologies like static RAM. The main memory is off chip somewhere on the PCB. It takes many clock cycles to get to it. It is very large, but somewhat slower. So if the caching the cache is operated exploiting the temporal and spatial locality, then from the point of view of the processor will see a large memory address space offered and created by this memory hierarchy, at fast accessing times. And this illusion that the processor has, that it works or operates with a large memory address space at fast access speeds, is really made possible or enabled by operating the cache according to, or taking benefit, exploiting the principle of locality, which makes for the caching concept to work. And there are two types of locality: temporal locality and spatial locality. The temporal locality refers to the fact that items accessed recently are more likely to be accessed again soon, and that is why in the library analogy, we would replace first the books that were least recently utilized. And this way, exploiting the temporal locality and increase the chances for those books or that data that exists in the cache to actually be the one that is needed by the processor. The spatial locality means that items that are near those accessed recently are more likely to be accessed soon rather than later on. So, for example, elements of an array, as you would iterate through an array, the elements that are in the vicinity of the elements that you just utilized are more likely to be needed in the near future rather than in the far away future. So it is this principle of locality that is being exploited by the caching concept that creates once again the illusion to the processor that it works with a very large memory address space, but at a very fast speeds. I hope this is clear, and I'll see you in the next video.